Alright, so our system is logged in right now, so we'd go to psc.local in the address bar, and once you enter the Wi-Fi information and password, it should show you the correct information here. So this is our settings menu. This is directly connected to the controller, which you'll have access to at any point in time. First thing you'd select is your pump and or steering assist system. So in this case, for example, we have 2010 Mazda, 2014 to 18 Altimas. They're actually slightly different. A Volvo pump and a mini pump. W164 is a European model only, but is still viable. So the reason for all this selecting is you need to tell the controller what information to send. So in this case, I have right now on my test bench a BRZ column from 2014. So I'd select that. Mode, we're going to start off with full manual, as that is the most defaulted usage of it. Startup delay time, it basically signifies exactly what it says. It's how many seconds it's going to take to the controller to actually turn on the pump. So if you want some sort of delay for any reason, go for it, select it, and you're good to go. We're going to ignore the generic outputs for now. We'll get to that a little later. Pump limits. So this is mostly used for the electro-hydraulic power system. So Mazda, Volvo, Ford, not Altimas, such things as that. Now the reason for that is, generally speaking, anything under 40% in some of these pumps is actually completely useless. It's more or less the exact same level of assist, which is nothing. So if you want a little bit more control and you find out, hey, about 38% is where I'm happy with sitting, then you'd select that. If it's too much assist, dial that down, the usual. For now, we're just going to keep it all maximum. Next, once you've connected for the first time, you'd want to calibrate your controller. So you'd connect your potentiometer or whatever you're using it, click calibrate, and you're going to dial it up all the way. You'd click grab high, dial it all the way back down, click grab low, and you'd save it. There we go, calibration completed. Now we continue on. This is now a fully functional and operational system where right now you will dial the level of assist up and down using your potentiometer. You can wire this potentiometer to almost anything, including a hall sensor. Most hall sensors to 5 volts will be more than compatible with this. You can also connect it to, say, your interior light switch. Some vehicles have dual switches for no particular reason. You can just wire it into the second one. Well, next mode we have is single value. Now, single value is not really particularly useful for daily driven cars or proper racing cars. You'd mostly use this as a drifter. So you'd want a same level of assist the entire time. So you would select which level you prefer, again save it, and you're golden. Next mode we have is PWM. So this is useful for people who do not either want to use two different systems, so say your engine computer standalone or the controller, you'd prefer to have everything all in one. So what you can do is do the basic setup for once, and that's it. Now there's an input pin on the controller to which it will be listening for a duty cycle. So you can connect that to your engine computer and use the logic there. The controller is just going to be a slave listening to a duty cycle and outputting appropriate information to the steering assist system. Next mode we have is let's go with VSS map in this case. VSS map, you're going to have two options, digital VSS and CAN VSS. Digital VSS is for people who have a VR sensor or a hall sensor for speed. So we're going to start off with that. You'd select the amount of missing teeth on your trigger wheel, and then you're going to enter the full wheel diameter. So that's the entire tire, not just the rim. This gives us enough information to calculate vehicle speed on its own. This map is the OEM equivalent of how they control your assist here. So you'd select under lower speeds a higher pressure or higher assist level. This is mostly for parking lot driving and low speed maneuvering. And as you go further along, you don't need as much assist due to the dynamics of the vehicle, especially if you have plenty of caster. Basically, you can select whatever you want to your heart's desire. It makes no difference. And once we save that, we're in VSS mode and we're golden. Next mode we have is CAN VSS. So it's the exact same thing, but it's assuming that you have already a controller on your CAN bus that is reading data from the vehicle speed sensors or a wheel speed sensor. So you'd find out your address of where this information is transmitted. You'd find out which 2 bytes are responsible for this, and you'd select the bit length. We also have some canned systems already figured out, like AAM, the BMW ABS systems, GM ECU, GM TCM, but most of you are going to be using probably custom for your standalones. Next feature we have, is CAN. CAN 0 to 100. This is extremely useful if you still want to use your engine computer to drive the controller, but you do not have any more input outputs. So you'd select CAN 0 to 100. Unfortunately, there's a bug right now where it's not showing you the address and all that selection. But you'd do the same thing. You'd enter the address, you'd enter your information, and the control byte where your engine computer is going to be outputting this information. Another very useful feature we have is the outputs. So in this case, they're more useful in VSS, digital VSS mode, because you'd connect your VR sensor or your Hall sensor to the controller. Controller still does all the calculations of the vehicle speed and assist, and you're able to select one of the outputs to VSS mode. This creates a frequency output from my controller to the engine computer. It is basically an emulation or a VR conditioner for your engine computer. So if your ECU is unable to get a vehicle speed sensor for some reason, or your dashboard isn't, well, our controller can create it for you. The next option we have here is for duty. Duty basically means it's more of a feedback system. So if, for example, your engine computer is commanding 50%, for some reason it's taking a little while, this would output a feedback to your engine computer showing you what the actual percentage control is at this point in time. The next output we have is error, so basically it will pull the wire low when you have an error, so it'll light an LED or bulb or trigger a relay or input into your computer. Then the next and last thing we have, this is on debug mode right now. We can ignore everything on the left side. This is going to be hard-coded and dynamically set up. The Wi-Fi station mode is what you will have access to. So if you have a hotspot or a router for some reason in your vehicle, most like high-level race cars do, you can read and set up all the information through your router, or it also has a useful feature where it's easier to update with it. So instead of downloading the firmware update to your laptop, disconnecting the laptop Wi-Fi, connecting to the controller and manually uploading it, you can select the station information and click update, and it's going to automatically download the update by itself and load it up. And that is basically the gist of the system. Thank you for listening.